How many of you know what is an agent? Agent. What is an AI agent? Very simple question. Anyone can raise your hands and speak. What is an AI agent? Give me an example of AI agent. Give me an example. That is not an agent. Chatbot, not exactly.
A part of ChatGPT.
Yeah. So let's say Swiggy. Swiggy is a good example. You have ordered food, lot of time, right? You got a bad order, spillage, blah blah blah. Now, you went to the options. You simply said that I want to return this order. Now, many times you are not assigned a customer executive, right? Is that you submit the images and automatically you get some amount of feedbacks. Now, we do not look behind the logic of things like how it's done, but that is an agent which figures out that what was your AOV, average order value, at the back end. How often do you do this? You report spillage and return, and then it checks that okay, should we return a certain amount of money or should we escalate to a human person? So agents are something which have the AI component and they have the ability to make actions. That is the most important. They can make actions. Right? So again, before starting, these are the few terms. How many people do not know what is SIM? Raise your hands. Everyone knows? What is CSERT? How many of you do not know what is CSERT? Everyone knows. You do not know CSERT. Okay. So CSERT is a team in any organization. Let's say there is any kind of security incident. Like, let's say, very simple, a server got hacked. So the team which investigates, computer security incident response team, this is the team which is involved, and they are called, like, please investigate how it happened, tell us how to patch. So they are the ones. Now, in the same way, please tell me what is it? How many of you do not know what is PSERT? Okay. It is very simple, but on the product side. So product security incident response team. So let's say you have a product, like Swiggy is one product. You have an incident in that particular product. Then this team is. So on the application side of things, if incident happens, if there is a vulnerability, they go with PSERT. Now what is threat detection? Anyone? No? Okay. So let's say there is a new vulnerability. We were given 3 security snacks, right? Now let's say you are in the organization and this is a very new vulnerability. You are not aware of it. You have the servers which are vulnerable. How would you detect that someone actually attacked and they have gained initial access into your organization? How will you know? But regular scans even identify the vulnerable servers. But how will you identify someone gained access? Logs, right? But how do you like? You cannot go and check the entire logs, right? So for this, so what does SOC use for this? SIM tools, exactly. So the team which writes rules inside SOC, SIM tools, they are part of SOC. They are known as threat detection team. Now what they do? They firstly create a threat model. So let's say there is a vulnerability. So they create a threat model of how attacker can go from point A to B to C. From initial access to lateral movement to privilege escalation, they threat model everything. And based on that threat model, they create detection rules. That if I'll give you a very simple example. You all know all about session hijacking, right? Suppose I stole your session and logged into my own browser. How will you detect? What anomaly? No. So it's a very simple logic that if I stole your session and logged into my browser, So my browser will not have a login event associated to it. Only your browser will have it. Your IP will have it. That's an anomaly. So that's what you need to like thread model and come up with. What is the logic? How can we catch this with the events and logs we have? That is threat detection. Finally, what's a prompt template? No, not exactly. I will define what's a prompt template. So let's say you have a very repetitive task that you want LLM to do. You want ChatGPT to do. You want to give it some data. How many of you are worked it? No one? So let's say you have a vulnerability of XSS. And every time you have to report it, you have to just go manually create the report. So what you do, you create a prompt template with a section where you place all the technical data, give it to ChatGPT, and it will generate a report according to the prompt template preset of instructions that you have given. This will be very uniform kind of output. So this template where you place your input data and the LLM processes it accordingly. That is called a prompt. Clear? Now we can move to our presentation. So you guys, this is all about me. My hobby is vulnerability research and threat hunting. And you know what is CVE? So I have 18 CVEs assigned to me. And I have also found many vulnerabilities in critical pen testing exercises of NCIPC, and I'm currently an intern of Salesforce doing this particular thing. If you want to connect to my LinkedIn, you can simply scan this code later. It will be shared in the now. Another question is, what is IOC? What is mutualism? Okay. So let's say there's a malicious hacker. You are the defenders. This is the organization. Now I throw something at you, right? Now this is the event. This gets logged. So whatever activity that I do in your organization, which could indicate that a compromise has happened, not will happen, has already happened, is known as indicator of compromise. So let's say this is one row, this is second row, right? Column second row. I threw something over here. Now this is a IOC that has already happened with this part. That part will know that this particular file is being sent in a phishing campaign or some other kind of attack. They will have the hash. So if I throw the exact same file at them, they will be knowing that okay, this file is malicious. So that is IOC. So again, why do threat detection teams need IOCs? So there are a lot of new malware families coming up, new variants coming up each day, and you have to keep up with them every day, which is a very big hectic task. Not only these malware families, you have vulnerabilities. Let's say we have a vulnerability and a threat actor is exploiting that for botnet or ransomware. So this is a continuous stream of data that comes every day. So today's organizations, they simply rely on manual processes for analyzing everything, IOCs, then creating detection rules that goes into SIM platform. Now, this is very hectic process if you are a very small team. Let's say even if you are a very big organization, then the scope increases and you have a lot of backlogs. Again, reliance on the manual methods, they have negative consequences, like you need to work on the skill development of whatever employees you have. Then there's also a chance of human error. Right? Again, quality assurance. Let's say I am a threat detection engineer, you are a threat detection engineer. So the logic that I jot down, and the way you will try to detect it might differ. Right? So there is a variance in how we write the rules. So what are the challenges faced by it? Operational inefficiencies. So they have to like process this malware samples inside the sandbox. Then known samples they have to do again and again, analyze it. And IOC extraction is a very time consuming thing. Again, manual rule creation increases the risk of human error. Resource constraints. You don't have all your employees sitting for just IOC based detections. You have to create a lot of detections which are not IOC based. So IOC based and vulnerability based detections are always at little lower priority than other ones. Then integration challenges. Now let's say, I'll take very simple example. I'm a company A, I acquire company B. We used to use SIM 1, they are using SIM from a different vendor. How do we integrate? So for example, if I have to create IOC based rule, I have to create it for my SIM, I'll have to create it for their SIM. So this environment is called heterogeneous environment, where you have different technologies working in sync with each other. This is one integration challenge. Then what do you have? You have quality assurance issues. So you will need 10 people to sit down, review each rule. Is this rule according to how everyone writes it? Is everyone able to understand it? If you do it for IOCs, it's very time consuming. You would not want to do it for IOCs. Now, let's take a scenario, what I was explaining to you. There is a new malware or vulnerability. This is a new CV, critical Windows zero-click vulnerability, right? Which gives you IOCs based upon vulnerabilities like CVEs. From there, you get the list of the IOCs. It's not visible clearly over here. And then finally, you create the rules. Now, again, for each platform, you will have to write it differently. Because each have their own syntax, each have their own operations and how they process data. Now, is the problem statement clear to everyone? Any questions? Okay. Now, this is the solution that I have come up with. I'm sharing with you all. So, this is the architecture of how we are solving this problem. So, firstly, if you have a malware sample, then you need to extract the API, IOCs first. So, what do? You create a IOC extraction layer. You automate all the sandboxes so that malware submission and IOC extraction is a very seamless process. You submit the samples, you get the IOCs in an API kind of thing. So you have the, again, let's say there is a sample. Now you have previously analyzed it. Would you want to analyze it again and again if it comes for the second time? No. You would want a database which stores the samples that you have already the knowledge of. You would only want to extract the IOCs from the newer samples. Then there are a few companies which provide you the IOC indicator of compromise database on stream for some price. The best example would be CrowdStrike. And their stream of IOCs is very, very curated, and it's actually what threat actors are up to, what they are doing based upon that. So you have the IOCs now. What should be the next step? This is the agentic layer. This is where all magic happens. So you have prompt templates. I explained you what is a prompt template, right? Let me show you. So this is a prompt template. I don't know if it's visible. Wait, let me zoom. Is it visible?
Yes.
Let me show you the first one. So this is the rule generation prompt template. That you are a wait. This is the one. You are an expert in creating Sigma rules based on provider analysis. There's the task, and then these are the inputs. where you provide all your inputs. Clear? This is a prompt template that is sent to the LLM with the data that we have. So you all got what is the prompt template, right? Now what comes? When you have the prompt template, you pass the IOCs to the prompt template, you send it to the LLM for rule generation. Right? So now you have a rule. Now, how do you validate it? Is the rule correct? Is the rule wrong? How do you do it? So the rule format that I am using for this purpose is called Sigma rules. So are you aware about Sigma rules? What are they? Not that Sigma rules. Real logic. This Sigma. What does it say? Shareable detection formats for all security professionals. With this diagram, it should be very clear to you. You have one detection rule in YAML, which, when passed on to Sigma converter, can convert into LStack, Defender, CrowdStrike, Simologic, Splunk, RapidSearch, all these things. So it supports around, let's see how much. 3,000 detection rules of different types. So they can be converted into 3,000 types of rule formats. So basically you create one rule, you have the rule for all, but with a slight complication. What is the complication? I'll come to later. So you generate the rule. Now the rule should be in YAML format. If it's not, you need to recorrect it, right? So you again send the generated rule back to the LLM after you have validated if it's a YAML rule or not. So if it's not, it will correct it. Then again send it back to the LLM layer. At LLM layer, you can have it API based like ChatGPT, Gemini, or you can host your own model like Mistral. Now you have the validation layer. So YAML validation is there. Then you have created the Sigma rule. It has to be validated again using a Sigma binary. Have you ever done Yara rules? So Yara rules have a binary form, right, for scanning the files. In the very same way, you have a binary for this. And finally, the pipeline review. What is pipeline review? I'll come to this very soon. This is how it happens. So you submit the hash, you get the IOC, you give it to the prompt template for generating the basic rule, LLM, and then you send the initial and the corrected rule for validation. If it's a success, you have the final rule. If it's not a success, you send it to something called rule correction template. So it takes all the errors, tries to fix it, and this cycle you can specify 3 times, 5 times, 10 times, based upon how many times you want to go for the correction. Now this is all theory, right? I implemented it practically, because if we don't implement it practically, we will not know how effective it is. So I got a Gemini key, API key. Then I did the initial rule generation and started a validation loop. Now, since Gemini has a limit, right? It can take a certain tokens at once. And if you give it too much data, it also hallucinates. So to avoid hallucination, what I did, I passed only 30 IOCs at a time. Passing on 30 IOCs, 30 IOCs, 30 IOCs at a time. So let's say you have 120 IOCs related with one sample, so 4 times. This is for the refinement. Finally, there should be one more. Yeah. This is the basic rule creation guide. Basically, this is the documentation of URL by Florian Roth. So basically, he's the creator of the Sigma project. So it's the documentation of him, how to write Sigma rules. These are the guidelines. Now, we need to validate whatever we have done, right? So we have to take some samples, create the rules, and then uh, put the rules inside some sim platform and see how many rules are scanning the malware or the events correctly, right? So what we did, we created synthetic malware samples. Why synthetic malware samples? Because in validation you need to get results which are repeatable. You cannot pick random samples every time. So I generated malware samples which were of different types. So one would do reverse shell, one would something DDoS, another would encrypt files in different formats like exe, batch, PS1, PowerShell. Then what did I do? I ran all the samples in my local sandbox and that had sysmon installed. So I got all the logs of all the samples. So whatever IOCs were there in those samples now were inside the sysmon logs. What is the next step? I imported all the logs into Splunk, which is a SIP. So here you can see all the logs are there. Now, before you are going through a test, you should know what is A grade, B grade, C grade, right? You need a like matrix for evaluating everything. So this was the matrix I went through. So first is AI model efficiency or rule generation. So let's say if AI is able to generate the rule in the first time, is it taking a correction loop? Is it taking two correction loops, three correction loops? How many correction loops? Depending upon the AI model, it can be ChatGPT 4.0, it can be 4.0 mini, it can be 3.0, right? So for different models, the results vary. So that is the first one. The second one is we have generated the rule. But what's the guarantee that this is going to scan the logs and come up with the findings, right? Maybe the rule is hallucinated. So we need to validate the rules. So these are the two matrices on which we like benchmark this. So these are the validation results. These are the models of Gemini. Gemini is free to use, by the way. If you didn't know, you can use the API keys for it. In the first cycle, rules were generated for 72. The second cycle for 11, and four of them simply failed because I had only 3 loops. Then in 1.5 flash, the results were like worse, but it failed only one. In 2.0 flash, I never had to go to the third cycle of correction. All were generated in 2 cycles. And I didn't have, if you went with 2.5 Pro, I think maximum would be in first cycle. Because that is the best model Gemini has right now. Again, so this is pretty good, right? We can test which model is working better, which model is working not. Okay. So, this is the matrix that how many samples were actually alerted by the rule, how many did not. So alerts were generated only for 67 samples out of 33 were not reported. It went as a false negative. It was very embarrassing at first. Maybe I failed. Then I started witnessing that, like, why did it? I started investigating why did it happen. So I went through all the logs. So this is the IOCs that I built first and then implanted into all the malwares. So I had a list of all the IOCs which were going to be there. Then I searched that why is this particular suspicious data.org not coming up? So I opened the CSV export of the sysmon. Everyone knows what is sysmon. Anyone who does not know? Raise your hands. I'll explain. Yeah, okay. So Windows has a set of tools, it's called Windows internals. You can simply search. So sysmon is one of their tools which you can install. It does logging of all your system events. So you get the log of all the activities in Windows. Clear? It's a logging. I saw that suspicious data was not in sysmon logs. That means this is not actually false negative. Did you get it? Basically, the IOCs did not show up in sysmon. Sysmon was not able to pick up those IOCs. So it was not in the log. If it was not in the log, it would not have been alerted by the rules. This is the actual. So we have true positive 67, true negative, unintentional but true negative of 23. That gives us accuracy of 100%. And again, this is by the 2.5 flash. So we did validate that this process that we have created, it works pretty well. Now let me show you the implementation. So either you can upload a file with the sample, or you can upload a CSV of all the hashes. So it will go to filescan.io. It's a sandbox like VirusTotal, but it's free, and its API is also free. It does not have any limit. You guys can use it in your whatever projects you're doing. The best part about this sandbox, it does the IOC extraction for you. There are very less sandboxes which do this particular thing for free. This is the generated rule. It has the URL, the domain, and the conditions. Visible? Now, when you put this rule, where did it come from? So basically, you have to convert the Sigma rule. So this is one of the platforms someone has built. So you have to put your Sigma rule. It will generate whatever platform you want to. Like here, I have selected Splunk. Right. So it will convert it for the Splunk platform, and this is the Sigma rule that was generated, and this is the Splunk query. Clear? And when I added it to the Splunk platform, these were the logs that it hit. And these were the accurately the logs that I intended to. Now the key findings. Let me ask from you. What do you think? What was the learning? What did we learn from this entire project? Anything you would like to add? Then we will move to key findings. Any key finding? Like what did we learn from doing this entire project? What matters the most while doing this kind of implementation? Any point? What? Alert notifications. Oh. Anything else? No? Automation. Okay. Tell me the factors which are required for good automation with less false positives. Better AI model, right? Latest MI model. Pre-training. That can be one of the things. So yes. Yeah, it can be. You can put a layer of RAG. Anything else? Oh, so let's go to key findings. This is the gist of the entire thing we did. That the successful validation was there. We were able to achieve our objectives, but the quality of log ingested, that matters a lot. Because if your logs do not have the IOCs, they do not capture the malicious stuff. No matter how good your rules are, they will not come up, they will not show, they will not generate any error. Right? Next is the quality of IOC sources. So let's say if your sandbox is not able to extract all the IOCs of the sample by doing static or dynamic analysis, you will not have all the IOCs. So you will miss on some. So the quality of IOC sources is very, very, very critical. You should have a very good sandbox for it. Or you should have a good vendor for getting those IOCs. What is the next? The ability of the LLM. Depends upon the model which you are using. A lot. By the way, OpenAI based models are not very good at this. Personal suggestion. What is the future scope of improvement? Remember I told something about pipelines? Let me show you what. So let's say this is a domain field and this is the value. What is the guarantee that the log you are ingesting and how the SIM processes it, you will have the exact same field as domain? You could have principal underscore domain, right? You could have local underscore domain. You could have different fields. If that is the case, no matter how we convert it, the rules will not work because it will not search for the correct fields in logs. How do we solve this problem? So there is something called pipeline. It's present by default in the Sigma. That when you are doing a rule conversion, you basically give a particular set of configuration files. These are very similar to like how log parsing works. So basically it will map your domain field to your custom domain field. This is the map. And this is not a repetitive process. For one log type you have to do it only once. You do not have to repeat. Now again, this, the platform which you have seen right now, this I am currently generating and I am planning to release it very soon. So it allows you to like map everything in a GUI format. Generally, you will have to write a configuration file, go into CLI, do it again and again. But here you can simply like map everything and just simply generate the output. So, what is the future scope of improvement? Generic detection rules require adaptation for different log platforms due to variations in log parsing, field naming, and data structure. So the field names can be different in Splunk, they can be different in Chronicle or Curate. So this is a proposed solution that I am thinking to work on again. Like, why to manually do it? Let's pass the configuration file of the parser. Let's automate this process. So you have the heterogeneous detection environments, you have the parsers, you have custom fields for logs. You take the IOCs, you map it to the raw fields like domain, IP, location. Then there is the initial rule. You pass it through a processing pipeline. You have the custom rules which are for your organization. Now you have the rule which is usable. If you do not understand, I can repeat. Want me to repeat? Yes. So you have a log of sysmon where domain equal to suspicious.com. Now if I import it to Splunk, it might appear as swiggy.domain equal to या फिर local.domain या target.domain equal to suspicious.com. Right? If I import it to SecOps or Chronicle, it might appear as principal.domain equal to, that is how it appears in SecOps. So these are two different fields, right? We do not have the logic for this. So when we convert our rules without pipelines, it will be converted domain equal to. If we put that rule in our SIM, it will not work. So for doing this, there is a configuration file called pipeline. You add the pipeline while processing the files, so it will map your domain field to the field you have in your organization. Let's say target.domain or principal.domain. Clear? So I was saying that you have this logic of which field is attached to which field inside the parsers for the log. So there should be an agent, you give the parsing logic, it will give you the pipeline.